Problem 55. Find the derivative of arctangent x over e to the sine x. Since arctangent x is being divided by e to the sine x, that tells us we need to apply the quotient rule. Remember, the quotient rule is given by this. If we have u divided by v, we take its derivative. This gives us v times u prime minus u times v prime, all divided by v squared. In this case, u is arctangent x, our numerator. V is e to the sine x. In our formula, we also need u prime and v prime. So let's compute those now. U prime, the derivative of arctangent x, is 1 over 1 plus x squared. V prime, the derivative of e to the sine x. Well, to evaluate this derivative, I see that sine x is the argument of this exponential function. So that says we need to use the chain rule. The derivative of e to the sine x is e to the sine x times the derivative of the exponent, which is cosine x. We've got our pieces, now we can plug them into the quotient rule. So this tells us that y prime is equal to v times u prime. V times u prime is e to the sine x times 1 over 1 plus x squared minus u times v prime, arctangent x times e to the sine x times cosine x. And this is all being divided by v squared, which is e to the sine x all squared. That's the same as e to the 2 sine x. Now here we have a compound fraction because we have a fraction in the numerator. Let's get rid of this by multiplying both numerator and denominator by our common denominator of 1 plus x squared. We multiply this on the numerator and the denominator. Distributing this through, on this first term, the 1 plus x squared will cancel, leaving us e to the sine x. On the second term, there is no denominator to cancel, so we just leave all 4 factors here. Arctangent x, e to the sine x, cosine x, 1 plus x squared. In our denominator, again, there is nothing to cancel, so we leave both factors, e to the 2 sine x times 1 plus x squared.